x plus a, 2x minus a. So this is what I'm going to have. So automatically from here, I can now cut this because this one and this, they are the same. So then my final answer will now be minus 3x plus a over x plus a. And if I want to rewrite this, I can write this as, this is the final answer anyway, or minus 3x minus a over x plus a. The third question of figure 1.1a, which is this. We have a squared minus 5a plus 6, and the denominator is 2 minus 3a plus a squared. So this is a quadratic expression. The numerator is a quadratic expression, minus 5a plus 6. But the denominator is a bit different from the numerator. So let's restructure the denominator such that it looks like the numerator. That means this a squared comes first. A squared minus 3a plus 2. So this is what we're going to have. Then let's call this num, just like I did for the previous cases. Then let's call this den. So if I want to talk about the num now, so I have a squared minus 5a plus 6. So I use this to multiply this. Then I have plus 6a squared. I will look for two factors that if I multiply them, I will get this, and if I subtract or add, I will get this one in the middle. So what are the factors of 6? We have 1, 6, then we have 2, 3. Which one will give, the product will give us this one, and the addition or subtraction will give us this one in the middle. There is no other one than this, minus 2a minus 3a. Minus 2a minus 3a will give us minus 5a. Minus 2a times minus 3a will definitely give us plus 6a squared. So this is, so anywhere I see my minus 5a, I will replace it with this. So, and if I want to resolve that, I'll have a squared minus 2a minus 3a plus 6. So I can dissect this into this. Then what is common here? A is common. A minus 2. What is common here? Minus 3 is common. A minus 2. So I factorize this. So I have a minus 2 into a minus 3. So this is my num. Then the den case, I have a squared minus 3a plus 2. So I also follow the same pattern. I multiply this by this. I have plus 2a squared. Factors of 2 that will give us, the product will give us this, and the addition or subtraction will give us in the middle. The one in the middle. Then we have 1 and 2. You have a negative here, automatically it should be minus 1, minus 2. And since we are dealing with a is the dominant variable here, so automatically I can say minus 1a minus 2a. But in mathematics, we don't normally write minus 1a because we assume that this one is invisible. So we can write minus a minus 2a. So we have this. So anywhere I see my minus 3a, I replace it with this. So if I want to rewrite this equation, this expression rather, I will have a squared minus a minus 2a plus 2. Then I dissect the expression to this. Then I will have a is common to this, a minus 1. Minus 2 is common to this, a minus 1. So this is what I'm going to have. What is common here? A minus 1 is common to both, so I can factorize that out. Then I'll be left with a minus 2. So this is my den. Then to my num, my den. My num den will then implies that what's my num from what we have done. That's a minus 2 into a minus 3. What is my den? A minus 1 into a minus 2. So these can cancel this. Then we'll have a minus 3 over a minus 1. So this is my answer for that. The last, which is the third question of figure 1.1. multiplication and division of fractions. This is done by factorizing fully first, then divide the numerator and the denominator by any factors that they have in common. Example, simplify the following. Question 3 in figure 1.1b. The figure 1.1b is on the board. You have 1, 2, 3. These are the 3 questions. Looking at the first question, we have a squared plus 2a minus 3 over a squared minus ab, minus 16 rather, minus 16, then times a plus 4 over a squared plus 8a plus 15. We need to solve this question in order so that we don't run into confusion. Let's call this A. Let's call this B. Let's call this C. And let's call this D. So the A now, which implies that A squared plus 2A minus 3. This A, we can factorize this. It's an expression which we can factorize. We can multiply this by this and we have minus 3a squared. What are the factors of minus 3 that will give us the one in the middle? There is no other one than minus 3 plus 3a minus a plus 3a minus a. So I can simplify this. Then I'll have a squared plus 3a minus a minus 3. So I can dissect this into this. What is common here? A is common. A plus 3. What is common here? Minus 1 is common. A plus 3. A plus 3, A plus 3. I can factorize A plus 3 out. Then I will be left with A minus 1. So this one is for the A case. The A is this. Then the B. The B has A squared minus 16. If I look at this, I can say A squared minus 4 squared. Recall difference of 2 squares. Difference of 2 squares. Then I'll have, we state that A squared minus B squared is the same thing as A plus B. A minus B. So B case now, I can write B as A minus 4, A plus 4 by difference of 2 squares. Then the C. There is no point tampering with C because C is a linear expression. You leave it. Then the D. The D is A squared plus 8A plus 15. Can we factorize this? Let's check it. We have plus 15A squared. What are the factors of 15 that will give us the one in the middle? There is no other one than plus 3A plus 5A. So then I can substitute this into this. I have A squared plus 3A plus 5A plus 15. So I dissect the expression. What is common here? A is common. A plus 3. What is common here? Plus 5 is common. A plus 3. So what's common to this? A plus 3. So I bring that A plus 3 out. Then I'll be left with A plus 5. So this is my D. So I have A over B times C over D. What's my A? My A is A plus 3, A minus 1 over B. What's my B? My B is A minus 4, A plus 4 times my C. What's my C? My C is A plus 4 over D. What's my D? My D is A plus 3, A plus 5. That's what I have done. Then here, if you look at this closely, you discover that this can eliminate this. 1. Then this can eliminate this. 2. Then what else? Then you rewrite what you have. You have A minus 1 over A minus 4, A plus 5. So this is the final answer to this question. Then the question 2, question 2, we have this. Let this be A. Let this be A. Let this be B. Then let this be C. And let this be D. Now let's consider the A. The A which has m squared minus a squared by difference of two squares, which is no longer new to us. Which is no longer new to us. We have m minus a, m plus a.